All right, let's do a nested analysis of variance using R. I've already entered the code here just to speed things up just a little bit. We begin by clearing the memory, so we use the command rm and then list equals to ls paren. The data that we're going to use are already on the web page. Those are nitrogen data for nitrogen content of leaves taken from trees, and to each group of trees a particular spray has been applied. And what we'd like to know is the concentration of nitrogen amongst these sprays different. So we use our read.csv function in order to open up the dialog box so that we can select the data file. We attach the data using the attach command, and then we look at the first few rows of the data to make sure that it's all in good shape. I would like to point out that in this particular analysis, we're not going to do anything with the leaf column here, but we have 3 sprays, and each spray is applied to a number of different trees, and then from each tree we've collected 6 leaves and then evaluated the nitrogen content of each leaf. So we're not going to do anything with the leaf variable. We don't need that number 1 through 6. We do need those nitrogen values. So now the next thing is we look at the structure of the data, so str and then nitrogen data, and that then tells us that spray has integer values, tree has integer values, and leaf, which we don't need, also has integer values. Nitrogen is numeric. So the next thing we need to do is change the nature of those data. So we're going to use nitrogen data $, spray, and then we're going to convert that to a factor. So spray is now a factor. So rather than treating this in a regression sense, we're going to be using it in an analysis of variance sense. Tree, we're also converting that to a factor, and then leaf, which we don't have to do because we're not using it, is also being converted to a factor. Then I'm calling up the NLME library, more about that later. We then construct the box plot, and we're looking at nitrogen as a function of spray, and we're labeling the x-axis with spray and the y-axis with nitrogen, and you see that over here on the right. There's our nice box plot, and from the box plot we can see that spray number 2 results in the highest nitrogen content of the leaves. Spray number 1 and 3 differ in terms of the variability that's associated with them, but whether they're different or not isn't clear. So now what we're doing is the analysis of variance, and our ANOVA model is going to be nitrogen as a function of spray. And now I'm using a command which is, or a sort of a term here which you're not familiar with. What I mean by this is it's a function of spray, but that trees are nested within spray. So we're talking about nesting in class, and this is one of the ways that I can make that point. And what R then does is provide me with at least part of the information that I need. And this is where many people get hung up when they're trying to do a nested ANOVA. Notice what it's doing. It's giving me the sums of squares and the appropriate degrees of freedom. So for spray, I had 3 sprays, and there necessarily I have 2 degrees of freedom. And it gives me the correct sums of squares. For spray, or tree nested within spray, I have 246.9195 as my sums of squares. And correctly, I have 9 degrees of freedom there. And then for the error term, for the residuals, I have 129.1425 and 60 degrees of freedom there. The mistake that many people make is they then test for the significance of spray. So they'll look at spray sum of squares divided by 2 degrees of freedom, use that as the numerator, and then as their error term they use the residual, so 129 divided by 60, and then they divide the mean square for spray by the mean square error, and they come up with a result which is incorrect. So in order to get around that, we need to treat this a little bit differently, and that's what we're going to do here. we're again doing the analysis of variance, and now I have nitrogen, and that's a function of spray. And now I'm adding plus error. So in a very real way, I'm telling R that I want my error term to be tree nested within spray. So it's the within term. So I'm not going to use my residuals as the error term, but I'm going to use this nested component right here. And when I do that, it gives me the same sort of treatment that I had before. So it gives me the sum of squares for spray. And notice now that the sum of squares for the residuals with 246.9195 and 9, that's equivalent to what I had up here for trees nested within spray. Okay, then down here it gives me the second stratum, and that's my residuals term plus 60. It also gives me this little error term here, which we're going to ignore. When it says singular, it means that I have some kind of function in there that's undefined or poorly defined or isn't behaving nicely. And that probably has something to do with the variance-covariance matrix. If I run this analysis in SAS, I'm not going to get that error, so I think there's something funky going on here. I'll have to dig into that a little bit and find out why it's doing that. But the result is, if I ask for the summary of the analysis of variance, which is what I'm doing here, so notice I have summary and then paren, and then I have exactly the same model statement here that I used above. It now gives me my ANOVA table. It also gives me the same error warning, which we're going to ignore. But if you look at this ANOVA table, this is the correct ANOVA table. So here are my degrees of freedom associated with spray and my within term, my trees nested within spray. There's the correct sums of squares. Here are the correct mean squares, and here is the correct F value and the appropriate P value. This is the correct ANOVA table for a nested analysis of variance. What many people do is they don't go to this step and they end up with the ANOVA table that is incorrect. Most people will use the error term, that is the error associated with leaves, instead of the within term to compute their F-test, and necessarily they get the wrong answer. So that, in a nutshell, is using R for a nested analysis of variance. Good deal. See you guys next time.